Welcome back. Let's talk about pyramids and how to find the surface area of pyramids. First of all, pyramids are different from prisms because pyramids only have one base. That base can be a polygon of various sorts. In this video, we're going to look at a square pyramid, a triangular pyramid, and a pentagonal pyramid. A pyramid is named according to the shape of its base. Now, all of the other faces or flat surfaces of the pyramid are called the lateral faces. In this pyramid here, we have 4 triangles that meet at the bottom here where the base is, the square is, and up at the top they meet at this point called the apex. The apex is the peak or the top point of a pyramid. Now, a pyramid has 2 different types of heights. There is a true height, or what we call an altitude, that goes from the center of this base up to the apex. It makes a right angle. And then there is a slant height, and a slant height follows the surface of one of these faces and meets at one of the edges of the base. So this would be a slant height here. We can find that distance in this problem in just a moment. We'll do that. The surface area formula for any pyramid is P, which is the perimeter of the base, times S, which is the slant height, divided by 2, plus capital B, which is the area of the base. So in this problem here, the perimeter, since it's square at the bottom here, we have 12, 12, 12, and 12. And the perimeter would be 48. Slant height, we're not given that value. I'll show you how to find that in just a moment. Then we're going to have divided by 2 plus the area of the base, which is a square. So it's 12 times 12, which is 144. Well, we need to figure out the slant height. I know that this happens, or this point here is at the center of the base. So it would be 6 units, perfectly half of this edge length. So this would be 6 here, and we have a right triangle with 6, 8, and then the slant height is the hypotenuse of that triangle. So we would use the Pythagorean theorem, 6 squared plus 8 squared equals, and I'm going to put S for slant height squared. That's 36 plus 64 equals S squared. 100 equals S squared. And you take the square root and you find that the slant height is 10, which we can put into our formula now over here. Well, if we simplify what we see there, 48 times 10 is 480, divided by 2 is 240, plus the 144, and we have 388. Now we're finding surface area, so it needs to be square units. We don't have a unit given, so we'll use U for units. And that's our final answer for the square pyramid. Now we can move on and talk about a triangular pyramid as well. A triangular pyramid will start with the same basic formula, but we can adjust the parts as needed. Over here, we have a base that's a triangle. We're going to assume on all of these that the base is a regular polygon. If it is not a regular polygon, the process would involve finding the area of each surface and then adding those all together. But for our examples here, we're going to assume that the base is a regular polygon. When that happens, this formula is able to be used on any type of pyramid as long as the base is regular. Well, we need to know what the perimeter is, and if it's regular, that means they're all going to be 14, and there are 3 of them, so that makes 42. The slant height right here we're given is 10, and by the way, the slant height does make a right angle with that edge. Divided by 2. If we continue our formula, the area of the base Well, we don't know exactly what that is here. The area of the base, it's a triangle, so we need to have the base of the triangle. I'll do that right here. The area of a triangle is base times height divided by 2. And I have that the base is 14. And I don't have the height right here. I'm going to just choose a number just for our example, even though it may not actually work perfectly for a triangle to have these dimensions. But I'll just go ahead and put an 8 in here for our calculation. So the height of the triangle is 8 divided by 2. And 14 times 8 divided by 2 is 56. And that is the value for B, the area of the base. If we continue, 42 times 10 is 420, divided by 2 is 210, plus 56, and we get 266 units square. We'll go a little further now. One more example. This time a pentagonal pyramid. In this pentagonal pyramid, we have this value, which is from the center of the pentagon to an edge, making a right angle. This is the apothem of this regular polygon. This is the true height. And then we don't have the slant height given. Now here's where we could draw it in. We could have drawn it in here, but it would have covered up some of the values, so I didn't do that. And then we have a length of a side at 6.5. Now we're making all of these have regular bases. So if the pentagon is regular, then it's going to have a perimeter of 6.5 times 5 sides. That's 32.5. We'll have to figure out the slant height, which we'll do in just a moment. Continuing the formula, we divide by 2, plus we need to find the area of the base. Well, the area of a regular polygon is perimeter times apothem divided by 2. Now the perimeter we just found, 32.5, so I can reuse it here. The apothem is 4.5, and then divided by 2. So if I put this all into the calculator, I get a value of 73.125, which I'll keep all of those for now. 0.125. Well, we still don't have the slant height, but I can do the same thing that I did in example 1. I can use the Pythagorean theorem right here. I would have, and I'm getting low on space, I'll do it over here to this side. We would have 4.5 squared plus 6 squared equals the slant height squared. And 4.5 squared plus 6 squared is 56.25. And if we take the square root of that, we find that the slant height is 7.5. Come back over here and put that into my position in the formula. 32.5 times 7.5 divided by 2 is 121.875 plus 73.125 is exactly 195, and this would be units square. See you next time.